So this is the 2016 Probability Distributions Exam, and we're going to do question 3. So, a small supermarket located in the city centre is open 24 hours per day. Between 10 p.m. and 6 a.m. each day, the mean number of shoppers who arrive at the supermarket per 5 minutes is 1.3. So we've got a mean, and it's per 5 minutes of 1.3. Using a suitable probability distribution model, calculate the probability that more than 2 shoppers arrive at the supermarket during a 5-minute period between 10 p.m. and 6 a.m. Okay, so we need to decide which distribution model we're going to use here. I want you to pause the video and have a think about it. Hit play once you've come up with a decision. Okay, so here are our options for this course. So the first thing we need to decide is the variable that we're dealing with a continuous variable, that means one involving measurement, or a discrete variable, that means one involving counting. If it's continuous, we could be dealing with any of the ones in the right-hand 2 boxes here, so it could be uniform, triangular, or normal. If it's discrete, we're going to be using either binomial or Poisson. So what is the variable that we're actually interested in this question? Well, it's the number of shoppers who arrive at the supermarket during a 5-minute period. Now, with the number of shoppers, are we counting or are we measuring? Well, of course we're counting, so it means it's discrete. So therefore we're either looking at, which ones? Binomial or Poisson. So it says here that it's binomial if we're using it to estimate the probability of a certain number of successful outcomes out of a fixed number of trials. It's Poisson when we're using it to estimate the probability of an event occurring a certain number of times during a stated interval. So the key difference there is binomial is out of a fixed number of trials, Poisson is within a given interval. The interval could be time or it could be space. So, what is it? Well, here it's out of it's within a 5-minute interval, 5-minute period, isn't it? And there's no clear upper limit to the number of shoppers that could arrive in that 5-minute period. So it must be what? Must be Poisson. So naming the distribution, it is Poisson. So I'll use a Poisson model with mean, which we call lambda, equals 1.3. And I need to check that the interval for the mean is the same as the interval for the question, and it's per 5 minutes. So I need to write that, always write down the interval. So lambda is 1.3 per 5 minutes. And that's really important because the question's also per 5 minutes. So that means I can leave it as 1.3. If the question had been per 10 minutes, then I would have need to have doubled that to 2.6. Okay, so I want to know the probability that more than 2 shoppers arrive. So the first thing I need to do is I need to write that down. So I want to know probability, P brackets, that, and we'll call it X, is greater than 2. Now, if the greater than, less than signs confuse you, then that's perfectly fine just to put that in words. And you could just put more than or greater than instead of putting the sign. That's fine. That will not affect your grade. The next thing I need to do is to be really clear on what I'm doing. I need to draw a number line. Always draw a number line. What I mean by that is the range of possible values. So the lowest number of customers could be 0. We could have 1, we could have 2, we could have 3, we could have 4. And with Poisson, there's no clear upper limit, so we can just put ... And the question says more than 2. So we need to circle everything that is more than 2. So that's 3 upwards, okay? Now, when we do this on a graphics calculator, our graphics calculator will only work out x or less. In other words, it'll work out a particular value or less than that value. So it won't work out more than. So we need to actually circle what we're going to work out on our calculator. The probability of 2 or less and subtract that from 1. Let me show you what I mean. So I'm going to be going 1 minus the probability that x is less than or equal to 2. And again, if you struggle with those signs, you can just put, instead of that, you can just put probability that x is 2 or less. And that's fine. Okay, so grabbing my graphics calculator. So I'm going to go menu, I'm going to go statistics mode. Now, Poisson distribution is not on the picture, so I'm going to go F6 to scroll along, and then F1 is Poisson. Okay, do I want PD or CD? Think P for particular. Do I want a particular value, or do I want a range of values? Now, CD stands for cumulative distribution. So here I want to accumulate because I want the probability of 0 up to 2. So I'm accumulating more than one value. Now, I need to change it to variable, so I need to go F2. Now, my maximum x value there is going to be the 2. So I'm going to type in 2. And my mean is 1.3. And execute. And that represents the value I need to subtract from 1. Subtracting that number from 1. And showing my working. And I get 0.1429 to 4 significant figures. And I used my graphics calculator, so I should write GC alongside it. Cool. Okay, moving on to the next question. So, part 2. Between 6 AM and 10 PM each day, using footage from its security cameras, the supermarket found that in 94% of 5-minute periods, there was at least one shopper arriving at the supermarket. Discuss how the mean number of shoppers who arrive at the supermarket per 5 minutes between 6 AM and 10 PM compares to the mean number of shoppers who arrive at the supermarket per 5 minutes between 10 PM and 6 AM. So just pause the video and read this again a few times just to get clear on what it's saying. Important thing is to read the bottom paragraph, which is the goal. Okay, so what's it basically asking us to do? It's basically asking us to compare the daytime rate of customers with the nighttime rate of customers. Which one would you expect to be higher? Obviously the daytime. So we expect to find that. So always think about the context, think about what the question's asking you to do before you worry too much about the details. Okay, now we can focus on the details. What are we being told? We're being told that in 94% of 5-minute intervals, there was at least one shopper. So let's write that down. So let's think about what it's saying. It's saying 94% of 5-minute periods. What that means is that if you picked a 5-minute period at random during the day, there'd be a 94% chance that there was at least one shopper. That's one way of interpreting that. 94% chance of at least one shopper. So we could say that during the day, so 6 AM to 10 PM, to be specific, the probability that there is at least one shopper, so x is greater than or equal to 1, is 0.94. And then we can turn that around and we can say, well, that means that what's the probability of there being no shoppers? Or how many 5-minute intervals would you expect to have no shoppers during their daytime? Well, it must be the complement, it must be, so x equals 0 must be 1 minus 0.94, which is 0.06. Now, why is that important? Well, so there is a way of using the Poisson formula to estimate the mean if we know the probability that x is equal to 0. And in this case we do, we know it's 0.06. I'm just going to start by showing you the shortcut way of doing that. Okay, if you just want to know the short answer. And then I'm going to show you where it comes from for those that are interested. So the shortcut way is that the formula is that lambda is always equal to negative, and we call it log natural, of the probability that x is 0. So if I do that on a calculator, what that means is all I have to do is I have to go negative, and then I hit the ln button, which it looks like n, but it's actually ln, so it's here. And the probability that x is 0, I'll put that in brackets, so that is 0.06. Close the brackets, execute, and that's my answer. So 2.813 to 4 significant figures. And the units are what? Customers per 5-minute period. Okay, so in a moment I'm going to go through and show you where that formula comes from, but for those that just want to know a quick way of doing this if it comes up, that's the formula you'd need to memorize. So we were asked to discuss how the mean number of shoppers who arrive at the supermarket per 5 minutes in daytime compares to the mean per night time, or per 5 minutes at night time. And so what was the mean per 5 minute interval at night time? It was 1.3. So as you'd expect, it's much higher. This estimate of 2.813 customers per 5 minute period between 6 a.m. and 10 p.m. is much higher than from 6 p.m. to 10 a.m. In fact, over double, isn't it? Over double, because it's over double 1.3. So it's over double the mean of 1.3 found between 10 p.m. and 6 a.m. And that's what we were asked to do. We were asked to discuss how the mean number of shoppers at daytime compares to the mean number of shoppers at night time, and we've done that. Okay, just as a wee aside, I'm going to show you how this formula works. You can skip this bit if you're not wanting to get into that detail at this stage. So how it works is that once we know the probability that x is equal to 0, if we substitute that into the formula for the Poisson distribution, and to find that formula, we can go to our formula sheet, and here it is. And it looks horrible, but it actually simplifies when we substitute the probability that x is 0 into it, as you'll see. So we're going to just copy this formula down. And this formula, by the way, can always be used to work out Poisson probabilities. Most of the time we just use our graphics calculator, or we use the tables if we don't have a calculator, and that's what we need. But this is the formula that generates the numbers in this table, and it's the formula that generates the numbers on your calculator when you use that. So let's just write it down for a start. Now, you don't even need to know what most of these symbols mean, but it's good to know that, but you don't actually have to for this course. All you need to do is realize what happens if you substitute 0 in for x. So if we write this formula down again and we substitute in 0 for x, let's just see what happens. Well, if we look at the first part of it, lambda to the power of 0, what happens when you go anything to the power of 0, except for 0, of course? Like if you go, for example, 3 to the power of 0, what happens? 3 to the power of 0, you get 1. If you go 100 to the power of 0, you still get 1. And there's a very good reason for that. I don't want to go into it in this video because it's not the topic of the video, but that's something you should ask your teacher if you've forgotten about that. And lambda is just a number, so whatever it is, if you put it to the power of 0, it's going to be 1. So that's just going to be 1. And then we've got e to the power of negative lambda. E is a number. It's a special number, a bit like pi is a special number. And it's actually, if we put it in here, it's actually, if we go shift, and then above the ln button we see e to the power of, and if we go e to the power of 1, that's e there. It's actually called Euler's number. It's named after a guy by the name of Leonhard Euler, and his name starts with E. So that's just the number, and then we're dividing that by 0 factorial, and 0 factorial is, if we work it out, let's have a look. So 0 factorial is just 1. So that's just going to be 1. So we end up with 1 times e to the power negative lambda divided by 1, and that, of course, is just going to be e to the power of negative lambda. So, therefore, we know that the probability that x is 0 is going to be e to the power of negative lambda, and that's how this all simplifies. Now, we know the value of that. We know the value of the probability that x is 0, and this question is 0.06, and they always will give you that information. So that equals 0.06. So we've now got the statement here. So e to the negative lambda is 0.06. Now we want to make lambda the subject. Okay, that's what we want. So to make an exponent the subject, we can use logarithms, okay? Because they will reverse the process and allow us to find out what the unknown exponent is. So the way we do that is we take logs. Now let me just explain what I mean by that. If I wanted to know 10 to what power was 100, now what is the answer to that question? 10 to the what? What's 10 to the power of what equals 100? Of course the answer is 2, right? So, because I know that 10 squared is 100. So another way of writing that is we could just say 10 to the power of 2 equals 100. And I could rewrite that as, using logs, as 2 equals log base 10 of 100. Okay, so then if I had 3 would be log base 10 of what? In other words, 10 to the power of 3 equals what? 10 times 10 times 10 is 1,000. So that's what a log does. Now we can do that with E as well, with Euler's number, because it's such a common number that gets used. Probably not in your life so far, but it gets used a lot in calculations involving exponents. So if we were to do that, we would end up with negative lambda equals log base E this time, because it's e to the power of 0.06. Okay, and then if we want, that's going to give us negative lambda. If we want to know positive lambda, then we're going to need to go negative log base E of 0.06. Now, there is a button for log base E, and it's this button here, and it looks like it says in, but it's actually log natural. And you can remember that because see how above it there's the e to the power of x. So that's the log base E button. So log base ln means log base E. So we can rewrite that as lambda equals negative ln of 0.06, which is what we did before. And in general, we can say as a formula, lambda, the mean, is going to be negative log natural of the probability that x is 0, if we use a Poisson model. So that's where that formula comes from. Okay, part 3. Discuss one other factor in addition to the time of day the supermarket should consider when modelling the number of shoppers who arrive at their supermarket per 5 minutes. Okay, so I want you to pause the video and I want you to think about this. So thinking real life here. Okay, so what affects how busy a supermarket is in your experience. Which times of the day do you, and which times of the week do you avoid going? Obviously, if you went at 2 in the morning, if it was open, you'd have a clear run with no queues. But stuff going at 2 in the morning, right? So, other things are going to be time of the week. And we need to, in statistics, we always need to support that by explaining how that might affect the variable. So, spelling it out, explaining the obvious. So, okay, what time of the week would you expect it to be busier? What time of the week would you expect it to be quieter? Well, obviously, when people are at work, which is during the weekdays, you're going to get less shoppers. You're going to get more shoppers just after work or on the weekends. So let's write that down. So less shoppers during working hours during the week. So the mean would be lower. And so we're talking, e.g. between 8 a.m. and 5 p.m. So the mean would be lower. Or we could say the mean used in a Poisson model should be lower during those times. And expect more during maybe the late afternoon or just before dinner and possibly also on the weekends. So the mean would be higher. So we've explained another factor and we've also explained how it would affect our variable. Okay, so looking at the marking scheme for that. And looking at part 1, we can see they got the same answer as we did. And you just had to calculate it correctly, and that was for achieved. Part 2, it says here, underachieved, if you calculated the new mean but made no statement, because you were meant to discuss or compare. So if you just got the numbers but no explanation, then that was only achieved. Or if you attempted to compare the means by considering probabilities, but maybe just didn't quite get there, didn't do it properly, then you would have only got achieved. For full credit, which was merit, you needed to have either lambda calculated correctly, so that's the 2.81, for 6 a.m. to 10 p.m, and compared to the mean for 10 p.m. to 6 a.m, which was 1.3, or if you correctly compared probabilities rather than means and reached the correct conclusion with a complete argument. So you can see here, if you pause the video, have a read of their model answer. Their model answer is pretty much what we had. If you look at the bit in italics, that was the other way you could do it as well. It was comparing probabilities and reaching the same conclusion, correctly concluding that the mean is higher for 6 a.m. to 10 p.m. Okay, on to part 3, possible factors. They had the same one as us, day of the week. And it says for merit, which is full credit, you had to have the possible factor and the effect on the model described. So if you just had the possible factor without saying how it would affect the model, even though that was kind of obvious, only got achieved. So always explain how your factor affects the variable involved. And in this case, the model. That was the bit where we talked about here where it said, so the mean used should be lower in these times, and then we talked about so the mean would increase. That was really important. Okay, we'll do the part B in the next video.